Hello, my name is Kennedy Sanchez, and today I'm going to teach you how to solve a real-life velocity function problem using the second fundamental theorem of calculus. But first, let me explain what the second fundamental theorem of calculus is. The second fundamental theorem of calculus states that if a function of x is the antiderivative of f of x, then the derivative of the integral from a constant a to x of the function of time is just f of x. If you take the derivative of the area under a curve from a fixed point to x, you just get the original function back, which is visible through the equation in the video. It shows how differentiations and integration undo each other. Don't worry, when we apply the theorem to our problem, it'll make a lot more sense. So now, let's get into our problem for today. So, our problem for today is a car's velocity in meters per second over time is given by the function the velocity of time is equal to 3t squared plus 2t for t belonging to the interval from 0 to 4 seconds. How far does the car travel during the first 4 seconds? Our first step is to understand what exactly the question is asking. We're given a velocity function, as mentioned earlier, and we're asked to find the distance traveled in a specific time interval, from time equals 0 to time equals 4. To find the total distance traveled, we need to integrate the velocity function over the interval. When we do that, we get that the distance is equal to the integral of the velocity of time from 0 to 4 with respect to time. This is a definite integral, and the second fundamental theorem of calculus tells us that we can compute it by finding an antiderivative of the velocity of time and then by evaluating that antiderivative at the upper and lower bounds of the interval. Now, you've heard the word antiderivative early in this video, but let me explain it a bit more. An antiderivative is a function whose derivative is the original function. So if you start with f of x, that antiderivative is a function f of x that when differentiated gives you back f of x. Now, with this knowledge, let's find the antiderivative of our velocity function. For our specific problem, we have to find the antiderivative of the velocity of time when it's equal to 3t squared plus 2t. To do that, we integrate each term, and when we do that, and also use the power rule of integration, we get that the antiderivative of 3t squared is t cubed, and the antiderivative of 2t is t squared, therefore making the antiderivative of the velocity of time, vt, equals t cubed plus t squared. Now, for our final step, we need to apply the second fundamental theorem of calculus. For our problem, the theorem says that the integral of the velocity of time with respect to time from 0 to 4 equals velocity of 4 minus velocity of 0. So now, using the antiderivatives we found earlier, we evaluate the antiderivative at the upper boundary, 4, and at the lower boundary, 0, in order to solve our equation. The velocity of 4, when using our antiderivative, is equal to 4 cubed plus 4 squared, which is then equal to 64 plus 16, equaling ultimately 80. The velocity of 0, using our antiderivative, is equal to 0 cubed plus 0 squared, which ultimately equals 0. Now going back to our theorem, we have to subtract the lower boundary from the upper boundary, meaning we do 80 subtracted by 0, which equals 80. And since our car's velocity function was in meters per second, we can say that the car traveled 80 meters in 4 seconds.